So I asked, yeah, am I audible, Sharmaji?
Sir, please.
Yeah. So I asked myself this question: who am I to speak to principals? That's a big question. So I looked inwardly as an octogenarian looking unto himself. Yes, I studied science. I have a PhD. I studied management. I have a PGDM. And I studied a bit of engineering because that was missing in my syllabus. I had teachers. Uh, I must make a small terminological inexactitude, which Sharmaji said. Professor Raman, only I have read about him. Dr. Baba was the teacher from whom I learned a lot of nuclear physics, then Dr. Sarabhai and APJ. I was a student in the training school after my graduation and post graduation. That's called the training school. And I had 50 scientists who taught me who had no B.Ed, D.Ed, or M.Ed. So I am an accidental product as a teacher phenomenon. Then I have been, as Sharmaji said, 40 years as a scientist and almost 60 years as a science communicator. I had the rare occasion of studying up to 10th standard in the Kerala State Education Board. Then I had the experience of my daughter studying in the Atomic Energy Central School CBSE syllabus. I had also the occasion to teach and learn with my two grandsons at ICSE and IBDP. So that's my educational journey. I have interacted with a number of students, a number of teachers, and I have learned through different systems. And have, as a scientist, I have a comparative statement of how these systems look like. But I am only looking at that small, narrow atomic fragment, the science component of the education. I also had the privilege of working with NEP 2020, Kasturi Rangan, who was my boss in the space department. And I have listened to him and his whisperings on education, which is very close to me. So that's the general situation. Recently, this month, I had an occasion to meet a group of teachers, interacting with them in Kerala and again in Kashmir. And I could have a real impact what they think, how they respond, and how they, in particular, demand from the resource person. Sharmaji, my slides have vanished.
Sir.
Let them appear.
Just a minute, sir.
Yeah, yeah, slowly, no hurry.
I thought I must see you what you are saying.
Nothing to see. It is the voice that makes. I'll try to make it as authentic as possible. Yes, here is your slide, and then it goes to next one. Yes, this is my interaction. First is interaction with a group of teachers in Kerala. Next one is in Kashmir. And here comes three great personalities. George Bernard Shaw. Bernard Shaw, and I want to prove him wrong, always said, those who know, they do. Those who do not, they teach. This classic, infamous definition from George Bernard Shaw is hurting all scientists. Those who know, yes, scientists, and they do. This knowing and doing, that is what education is. You must know and you must do. You must do and you must know. This synthesis between the two aspects, two verbs, because science is always a verb and not a noun, has been brought out by the eminent mathematician, philosopher, and metaphysician, Sir Bertrand William Russell. He said, science is knowing and doing things. He also went to the extreme conditions, the two sides of the wide spectrum, that knowing without doing and doing without knowing are equally disastrous. So from his definition, we get two anti-definitions: knowing without doing and doing without knowing. Kasturi Rangan, a true scientist, and that too in the pinnacle of physics, thought that science should be brought into education, not that education should become scientific. So this approach of a scientific approach, an eclectic approach to education was enunciated by him in the typical physicist point of view. So that's what we find in NEP 2020. So from Bernard Shaw to Bertrand Russell to Kasturi Rangan, we have the educational philosophies and the teacher's professional role going through three different verticals. Can I move to the next slide, please?
Can you see, sir?
Yeah. No, next one. Yes, we went through Shaw and Russell and Rangan.
Next slide, can you see?
Yes, next slide I cannot see, but
Okay.
if
I'll
others
again
see, it's fine with
put
me.
it.
Yes. Now we get into this next generation science standards. This was called a next generation science standards 20 years ago, but still we use the same expression, four-letter word, NGSS. And I ask the typical question, how, as a teacher, ask yourself this question, how dare you teach today's students to make them tomorrow's scientists with your yesterday's science? That is a paradox in the arrow of time, a true paradox in the arrow of time. There is a dichotomy, and addressing this dichotomy is what we are trying to look at science education. So the next generation science standards, or shortly called NGSS, is our objective, our goal, our strategy. And we move to that. What does it say? Yes, it says something different. Most of us are tuned to the wavelength that science means physics, chemistry, biology, maths, PCMB. And that has been the driving force, the prime mover in our education, right from my times, in the 1950s. And we are the products of that tunnelized vision. From here, we have to move further. In fact, we have to go into interdisciplinary, transdisciplinary, cross-disciplinary concepts. And that's what science is. You cannot know much about physics. You may know all about physics, but you may know nothing about chemistry. But in between, in the continuum between the two, you have chemical physics and physical chemistry. So the journey from physics to chemistry starts from physics, physical chemistry, chemical physics, and to chemistry. And then you get a larger and a broadened division. And that is what NGSS is trying to do that. So there are three concepts which are very essential to understanding the quintessence of NGSS. One, SEP, science and engineering practices. Now, the word engineering comes quite often, and most of us think that science is what matters, and science applied or applied science is what engineering is. If something is not applicable, if something cannot be demonstrated, and if something that cannot produce goods and services, and something that cannot produce significant and meaningful goods and services to improve the quality of life and the human development index, that science is sterile and barren and has no interest at all. Learning such a thing, going through a rote memory of those things, ability to reproduce statements from textbooks, definitions with the theory of relativity or Boyle's law or atomic physics, it means nothing to us. Life is larger than that. And life is not the single product. There is no singularity in the academic discipline. That's precisely what SCP says. Science and engineering practices, ask questions, model them, investigate, observe, look, see. Looking and seeing and observing are entirely three different dimensions of observation. And
WhatsApp audio.
Any directive for me, Sharmaji?
Sir.
Any instruction I got from you? No.
No, not at all, sir. Please.
Okay, fine. Yes. Oh, so here we have got the DCI, disciplinary core ideas, core concepts. And instead of physics, chemistry, biology, and maths, now we come to the other four things. Physical sciences, life sciences, earth and space sciences, and engineering sciences. Engineering sciences, an apparently contradiction in terms, but that's what really matters. Then we have the cross-cutting concepts, 7 cross-cutting concepts. That is the absolute irreducible minimum of what science education is. First and foremost among them is cause and effect. Most of us are not very familiar with the causal mechanism. Many of us are laboring under the erroneous illusion that a correlation is a cause. You can find two things happening simultaneously, but doesn't establish a causal mechanism between the two. So understanding the logical structure of what causes what. Is the relationship causal or is it accidental? Is it probabilistic? Is it statistical? Or is it linked by a physical mechanism? That's what NGSS wants students to understand. So we have the concepts, cause and effect, primary one. And then we have pattern recognition. We will take only two of that. There are much larger concepts in that. So we move on. Just remember these words: science and engineering practices, core ideas, disciplinary core ideas, and cross-cutting concepts. With that 9 words, we move to, can I have the next slide, please? Yes. Now you find a Mobius ring of practices, core ideas, and cross-cutting. This is the central theme of my talk. And you will find cause and effect on the top of it. That's what science is causative. This causes that. This doesn't cause that. That deterministic understanding of the universe and the phenomenon is what we are looking at for. Now, if you look at how we braid our hair, we will find a peculiar phenomenon. You need 3 strands, and if you bind them together, you will get the highest strength. And that's what all school girls beyond their uniform do that. This 3-braid hair brand which we make is what NGSS is trying to accomplish. It takes core ideas, it takes practices, and it takes concepts into 3. And then if you do it properly, the right time, the right sequence, the right quantity, right quality, then you get a performance expectations. So performance expectations are evaluated in the grudging scales of these 3 parameters. Can I move to the next? And if you want a simile or a metaphor to understand what NGSS is, you can treat the life cycles as vegetables. You can see the broccoli and the tomato and the potato. And incidentally, those plant scientist teachers will know that a tomato and potato can possibly be grown with the aid of engineering science in the same plant. The roots will give you potato and the fruits will give you tomato. So that's what science enables you to do. The possibilities inherent in that. And if you look at physical sciences, the metaphor that springs to your mind automatically is physical science is in the form of peats. Then we need our mixers and grinders and all sorts of utensils in the kitchen, and that give us the technology and engineering. Of course, we need earthy materials also from the airspace sciences, so earth and space. So these are the 4 disciplinary core ideas built into NGSS in metaphorical terms. Next one. Now, these 3 forces are saying the same thing. That's where our observation leads us to. NEP 2020 speaks about competency-based inquiry and localizing the context. If you can't localize, you can only speak about the vacuum or the space or the Western global North language, then that makes no sense. So NEP 2020 says that. And NGSS students explain real phenomena. I will give you some startling examples of real phenomena how students are explaining. Then we have PISA. Can the learner apply science to solve a real world problem? If you can't do it, there is no fun in your knowing that. And the bottom line for all principles is different documents, same demand, and usable science. Now, when spokesmen and advocates argue for different systems, you will find exaggerated hyperphonic arguments. But ultimately, reduced in analytical terms, we get to the same concept. No matter by what name you call it, as Shakespeare said, a rose smells sweet. Look at this picture. Yes. Maybe you are amused. Maybe you are amazed. This is contemporary science in NGSS and PISA pattern. I'm giving you an example. How do you explain a phenomenon? Very recently, 10 days ago, we have been familiar with the great discoveries and inventions of Nobel Prizes. October first week is all Nobel Prizes. But corresponding to the Nobel Prizes, we have a dirty mirror image called Ig Nobel Prizes. Ig Nobel Prizes celebrate those works of science which do not go into the mainstream, but they stand apart as a distractor. Here is a cow painted as a zebra, black and white, irregular lines. Why was this cow painted black and white? That's a question which anybody would ask, and you will look for a solution for that. Now, farmers will tell you that they have a problem in their cattle shed. That is, flies come in millions and start hurting and biting the cows. And then they found that if you do zebra lines on this, the attention of the flies can be diverted by, they will be confused when they come to these white lines and they do not bite and they go away. Experiment was conducted by students in GSS mode, and they found, they collected data, they analyzed the data. They came to the conclusion that painting a cow like a zebra gives it freedom from biting of flies. You may wonder, is it an earth-shattering discovery? Yes, it is. It is an earth-shattering discovery in the sense that it applies all the 7 parameters of CCC, the concepts which I mentioned a short while ago. All of them have been built into this. So how to apply those concepts, the disciplinary core concepts, straight into this cow? And that's an exercise for science teachers. Next one. That gives you, I'll share the slides with you. That will give you the observations and findings and conclusions. Next one, please. So phenomenon. Phenomenon is the singular, phenomenon is the plural. Phenomenon is the entry, the opening sentence of a class teacher. If you do not have a phenomenon to describe, if you are saying that pressure, volume relationship, Boyle's law is, if you are starting with a definition, you cannot go further. You stop there with the definition. If you start with a phenomena, it takes you through the whole concept of next generation science standards. I showed it to you with respect to the striped cows, the zebra effect. Yesterday, we had a very interesting discovery in science. Next one, please. Can I move to the next? Something very hot. We have the tandem solar cells. Energies, climate change, energy, options for nuclear energy, carbon-free energy, carbon neutrality, carbon zero. These are the words that cross through the mind. Element number carbon in the periodic table has been dominating for the last 1 year, our entire academic syllabus. And we have been trying to make solar cells, getting energy from the sun. There is a hydrogen-helium fusion reaction taking over there. Now they suddenly found out that there is a problem with the silicon transistor and there is a problem with the perovskite, the new semiconductor they produce. Suddenly by putting them together, not discovering anything new, but an accidental position, I wouldn't say accidental, a predetermined, designed position of perovskite on silicon gave you an entirely different picture. All their demerits vanished and merits appeared. This is how science moves. And you can apply all the NGSS principles straight into that. So we try to do how tandem solar cells, a news item which appeared in Nature 3 days ago, can be interpreted by the student and the teacher in the class by the fundamental principles of a 14-year-old student's knowledge capital or science capital, what they have. Next one, please. Yes, that I will share the slides with you. Next. Can we move a little faster because I am at 10:40? Yes, I have 20 minutes. Yes. Yes. Now, this is another interesting observation. Look at a cow. The cow gives, all living things give out carbon dioxide. I eat 1 kilogram of food and I give 1 kilogram of carbon dioxide per day. And everybody does that. And the cow does a little more because it is a cellulose consuming creature. Being a cellulose consuming creature, it produces, in addition to carbon dioxide, 2 other carbon compounds, carbon monoxide, carbon tetrahydride, that is called methane. Now, this methane is considered to be 20 to 30 times more harmful in terms of its impact on the environment. And therefore, we would like to know whether the cow gives out methane, and if so, how much. We measured, but then again, asking the question finer and finer, we found, does it give from its front end or the back end? And the impression was it was always coming from the back end. That's what the common sense view of it, or the traditional stereotype view is. But if you have a methanometer and if you move around and find out where the molecules are coming most in numerous numbers, then we will find that the methane is coming straight from the mouth. Now, I am not citing them as earth-shattering discoveries or inventions, but this is how science moves. And this is how this generation science students will be asking questions, because they have a methanometer which is very cheap and they can find out quantitative figures, they can build a database, and they can be scientists. So you are finding your students as scientists. Next one, please. Okay. Let us look at another classical example, the C.V. Raman effect on egg. C.V. Raman is a strict vegetarian, absolutely. But today, the widest application of Raman spectra is in finding out whether a chicken egg is male or female. If it is a male chick egg, and if it is allowed to incubate, it will hatch, and you will have a male chick, which will never lay eggs. So the reproductive capability of an egg is determined by Raman effect. All poultries, you can make a lot of money by deciding whether holding an egg in your hand and finding out is a male or a female and reject it. So this is an industrial application of Raman effect. Raman was looking at the bluishness of the sky and the sea, and absolutely the purest of pure, which we call the blue sky research. But the blue sky research has been applied by cross-disciplinary, interdisciplinary, and transdisciplinary concepts in an industrial process which delivers goods and makes money and makes nations rich or poor. So Raman effect and the chick, the connection is very, very tenuous apparently, but today we know how systems work. Next one, please. Well, we are all in shock for paradigms. Most of us are laboring under the illusion that the lovely squirrel is a nut eater, but it eats birds and eggs too. But that discovery is based on a scientific observation. Next one. Now, many of us are not aware that if I say I am 82 years old, I do not know whether my heart is 75 years old or 85 years old. Every organ in my body, the liver, the heart, the spleen, the pancreas, all of them have different ages. Now, this is what science has discovered, and this is what the generation is speaking about. Are we in tune with them? Can we engage them in a conversation? Science education is no longer a delivery of a deficit model. It is a conversation with the students. And we must understand in this age of knowledge economy and information explosion, they have a capital far greater than most of us. When I speak to my two grandsons, I think twice because they are two log cycles ahead of us. This dichotomy between the current generation, the next and the next, that's where we have to be smarter, not by harder learning, but by being smarter. So the body age and brain age, there is one sample of blood. The entire picture is available to us, and the data is available for the physician to interpret. Next one, please. Well, I have 45 minutes. Okay, I'll make a quick statement on how the different systems can be applied to a certain class. For example, most of us have studied how the preparation of oxygen in the class is a well-documented one. Every teacher, even in the dead of sleep, we've woken up and asked to explain how oxygen is prepared in the laboratory without any error, in typical and not in language. We will be able to explain it's done this way, that way. But if you have a choice to produce oxygen either by heating potassium chlorate with manganese dioxide or with the decomposition of hydrogen peroxide with manganese dioxide, then you will find NGSS, CBSE, ICSE, MYP. They have very different interpretations built into the same phenomenon. Preparation of oxygen goal is the same, but the mechanism, the pathways to lead to that are very different. And it is the pathways that decides how we do that. I have given in this the mechanism of preparation of oxygen by all the methods of pedagogy here. Next one, please. Okay, of all the elements, hydrogen is the simplest. One atom of hydrogen will have one proton in which one electron is revolving around it. We have the isotopes, deuterium, one proton, one neutron around which one electron is moving, and we have the still higher radioactive hydrogen, which has one proton, two neutrons with one electron moving around. That's what we know about it. But if you look at the structure of the hydrogen atom as it is being taught in CBSE, ICC, MYP, and GSS, you will find CBSE is more concerned with the energy levels and spectra. ICSE will speak to you about Bohr orbits and electron shells. But MYP of IBDP will link hydrogen to spectrum experiments. NGSS will give evidence of atomic structure via spectroscopy, the Raman effect. And PISA, of all things, will relate electron transition to real-world technology, the lasers and LEDs we use. Given the same material, the way the teacher handles in the system in which they are part of, that will give you the future of science education. Next one. So that's a comparative statement of a lesson framework for the atom as being taught contemporarily in our school systems. Next one, please. So we come to a popular view of science, science as the new citizenship. What is the science capital of a 14-year-old student across the globe? The PISA test is one of the parameters for this. I would say thermometric designation, but we don't have measurements for us. We are close to it, on the brink of it, but it is tantalizingly ahead of us. This alone will tell us that where we stand in the Committee of Nations with our systems of education. Next one, please. So science is citizenship. Now, I will quickly go to the managerial content of the learner principles here. So how do we strengthen the science pedagogy through principles leadership? This makes an assumption, assuming without admitting that strengthening is required because there is weakness. That's a correlative factor we derive from that. Science teaching that prepares students for life, not for just examinations, covering the syllabus to building capability. All standard stereotype expressions. Your role as a principal is to create a scientific culture. Next one, please. What do we do to do that? Principal as a culture setter, that's what we look up to you with great expectations. Next one, please. Yes. Now we come to what is known as the management matrix. Management is the art of getting work done through others. That's a classical definition of the Harvard Business Review. Management is the art of getting work done through others. It also has a correlative. Managers do not do anything by themselves. So if you look at the spectrum of managerial models available for principals, you will find that there are no less than 5 distinct models described in literature. You have the most interesting model, the servant leadership, the transformational leadership, the instructional leadership, the distributed leadership, and finally, as most of us have, the situational leadership. If you put it into a matrix, that's what managers do, or what MBA classes. In fact, today we have many principals who do their MA and MBA together. So they speak the language of a science teacher and a management expert and a pedagogy specialist. So that's the interdisciplinary concept now available as a professionals at the younger end of the spectrum. So I was consulting with some of these younger principals with these academic qualifications, and we are finding that they have an impact matrix, is principals leadership impact matrix. In this matrix, they have an x-axis and a y-axis. In the x-axis, we have the quality of science learning in the classrooms. The ultimate objective of all science education is quality of science learning in classrooms. And on the y-axis, we have principal leadership activation or actuated principles. On this y-axis and in a grid, where do we stand and where would you like to stand? That's the question we would like to ask ourselves. Yes, if we are in the compliance zone, the extreme left, we are very happy. Necessary and sufficient condition for promotion and for maintenance of salary. That's what the comfort zone says. You do what you do, Nothing will happen to you. You have an assured tenure throughout your professional life. And you are in a very comfort zone. That's called the compliance zone. And you will find that syllabus race, recall tests, practical files, copy work, students score, but cannot explain how they score. So that's a black box, or I would even call this is what we call not only a black box, but in cosmology terms, we call it a black hole. And most of us are happy with a black hole. No information comes out of it in cosmological terms from a black hole. That's the beauty about compliance. So now there are pockets of excellence created either by design or individual energy. That's what we call isolated islands of romance and beauty. Those isolated islands are created by teachers of exceptional merit, driven by their inner passion, and they create. Once that teacher goes, the island also vanishes. They're extremely personalized, not institutionalized. Individual excellence as uninstitutionalized. That's the lowest portion. Then, having read a lot of literature, interacting, attending seminars, and listening to speakers and resource persons and so-called big leaders, then principals get activated and they have a conceptual picture. Something should be done. And good intentions, but intentions are not actions. A well-meaning, conscientious principal, trained on the sensitive elevations of contemporary literature, will be familiar with all the concepts available with that. That is not a necessary and sufficient condition for action. So, no pedagogy shift yet. Principal talks NEP, NGS, as I did now speak about NEP, NGS, visa, everything you'll know in all micro details, nano details, or femto details. And the classrooms are still in the old traditional, absolutely unshakable way. And the message has not reached from practical. We know, we don't do. The knowing and doing dichotomy, the Russellian paradox acts on us. And we have a large number of people. In fact, I would even say Pareto's principle is applicable. 80 to 20 will be the ratio of the knowers and the doers. Then comes that rare, rich category, the science culture principle. Yes. And that's our target. What should we do? We should try to stand somewhere over there. There we have inquiry, investigation is normal, not abnormal, not paranormal. It is not special. It is the in thing. So that conviction, and at least one reasoning, one evidence-based reasoning in one class, one test, you have gone a long way. That's a classical takeaway from the practical asks, what did you see and why? The question why, the only question which is valid in the world is what Richard Feynman would say, why, why? If you can find a causative mechanism for that, it's a self-actualizing situation. And parents will hear and resonate and reverberate that science for life, not for marks. You can score a high marks, but you can't explain why a balloon becomes large when you apply more pressure. So that is the role of the principal. Move, not only you, move the school to the upper right quadrant. Let that be your ambition. Schematize it, draw your plan of action. And you must have a poem of the planning, organizing, executing, and monitoring. The principalship is a poem, planning, organizing, executing, and monitoring. And that monitoring makes you know whether your planning was right or wrong. Next one, please. Sharma ji, no. Yes. So we can have a weekend, at the end of the weekend, you can have a Monday morning action plan for principals. If you do only these 4 things this term, you are aligned with that. Ask every science teacher to begin 1 lesson per week with a real phenomenon. A real phenomenon. Require 1 evidence-based question in every science unit test. Run 1 sustainability linked SDG 17, take 1 of them. Water, waste, food, or energy. Give teachers protected professional development time not just for paperwork. Professional development. If you are out of touch with what's happening in a profession, whether you are a lawyer or a chartered accountant, you will be out of tune with that. Continuously, you should be in the frontiers of it. So professional development is an absolute necessity. Next one, please. Yes, from morning we'll go to Monday, we'll go to Tuesday. Sarmaji, can I have the next? I think I am close to back matrix we have done. Okay. Yes, AI in the science classroom. There are two aspects for it. The admission and entry of AI into different systems are very different. That you must understand. From a leadership point of view, as a principal, what will you do? What will you not do? That's very important. AI is already in the student's pocket. Siri is there, ChatGPT 4 is there, and Perplexity is there. Nobody is perplexed by this perplexity at all. So all that we can do at the state of art understanding is this: AI must not replace thinking, it must feed thinking. When you get an input from a ChatGPT, say on a lesson plan on hydrogen, you can also ask for compare it with other lesson plans from other systems, and you can find the gap analysis. So it is an aid, a powerful aid for the teacher. And AI can also be used to explore why and how. And the role is set that policy now. Do not, at the moment, do not allow students to make their submissions based on ChatGPT and the MHash systems. Next one, please. I have 2 minutes to go. Yeah, okay. Yeah, let's look at Michael Sandel, what he says or what he doesn't say. Okay, now schools, I mean, I'm just speaking in terms of commercial and trade terms, your school's brand advantage. That brand advantage is an intellectual capital, which is not the sum of the intellectual capital of the owners of the institute or the teachers of the institute. It is something which is a legacy, which is beyond the synergetic effect. And you can say to your parents, we deliver NEP in spirit, not in PDF. And our science periods follow global NGSS practice. And when we are PISA ready, we will show where we stand. We prepare students for PISA style problem solving, not just board recall. Yes, that's very important. In fact, I have been trying simulated PISA questions among the teachers very recently in October with about 300 teachers, and it was exceptionally rewarding for me to find out that the levels which they performed without preparation, unintended, was absolutely interesting, and the scoring was very, very high. Next one, please. Probably it's the last one. Yes. Without introducing Michael Sandel, that famous philosopher who taught us what ethics is, this. I don't know, I have explained this. I explain this to teachers all the time, like this. Now, we have a trolley, the classical trolley problem. The trolley is moving. It comes to a Y junction. Exactly at the Y junction, its brake fails. Momentum doesn't stop. The driver has only one option. It can either turn to the left or to the right. If you turn to the left, the principal and vice principal will vanish in no time. If you turn it to the right, you have the physics, chemistry, biology, NGSS teachers on one side. What will you do? And what will you not do? Turn to the left, the conventional system will vanish. Turn to the right, the emergent system might flourish. Very painful, poignant decision to make. Another complexity is introduced in ethics at this point of time, that the junction point, there is a very fat man. Shouldn't state that publicly, but yes, let's say the owner or the proprietor of the school, very high. If you can push that entity in front of that, you can save both. 1 versus 2 versus 5. And the principles they hold. This is the ethical dilemma which now is being taught in philosophy classes. Sharmaji, can I go to my last or penultimate side? 1102. Oh, yes. So I'm not asking teachers to work hard. There is always a red queen effect. Inquiring teachers run smarter and not harder. If you have your chat GPT as your soulmate, as a teacher, it will do wonders. Takes all the time running you can do to keep in the. You have to run faster to remain where you are today. If you want to be there where you are tomorrow. So this is the harder running which Lewis Carroll's Through the Looking Glass. I look forward to my last slide and bringing relief to my attendees. Yes. Our intellectual hero, education is not the learning of facts, but the training of the mind to think. Yes, I think, therefore I am. Information is a commodity. It's a perishable commodity. And it can be had at the tip of your tongue and at the flick of your finger. Anybody can have access to information, but your ability to process the information, your ability to process the information in the NGSS crucible, and your ability to find meaning in the information, and your ability, logical ability to find attribute significance to that information. That is what all education is about. And that is what science education is. Well, these are the thoughts of an old person. I share it with you and I leave you to think over it. Thank you. Shamaji, I am through and I look forward to a volley of questions.
Thank you, sir. Now the stage is all set for the principals to ask their questions, queries, or anything they want to ask.
Yeah.
Please.
Did you find that it was an unscientific way of looking at a science education by a scientist?
Shreyashi, you want to ask something? You are coming forward.
Pardon me?
A very good morning, sir.
Good morning, good morning.
Yeah, nothing to ask. The session was really thought-provoking, and it really left a lot of questions in the mind that, yes, are we really training the students to make scientific decisions, or are we really completing the syllabus and going after only the marks and the CGPA? So nothing as far to ask, sir. Definitely it is insightful. Thank you for such a thought-provoking session. Heartfelt gratitude from my end.
I am rewarded.
Good morning, sir. Good morning, Dr. Sharma.
Yeah.
And respected Dr. Jayaraman, sir. Thank you so much for such an interesting and enlightening session, sir. Your explanation of the next generation science standards, it was so lucid, inspiring, and as Shreyosi said, thought-provoking. And we truly appreciate the way you connected, scientific understanding with classroom practice and the school culture. And I completely agree with you. And thank you for giving us this phrase or this adage. Science is for life, not for marks or not for, GPA or ratings. So it has always been a privilege to learn from your vast experience and vision for science education. And on behalf of all of us, I express our heartfelt gratitude for your time, wisdom, and generosity in sharing your insight today. Thank you, sir, once again.
Thank you. Thank you so much.